Welcome back to another explainer. Look, right now the whole world is screaming, buy NVIDIA. They're dumping billions of dollars into the latest AI software and application layers. But if you actually watch what the smartest institutional funds are doing, the folks quietly allocating serious capital, they aren't chasing that mainstream hype. They're looking straight at the physical supply chain. They are analyzing the raw, heavy industrial reality of building a trillion-dollar AI cluster. Today, we're talking about the unavoidable physical bottlenecks that are literally keeping tech CEOs awake at night.
Which leads us to the trillion-dollar question. What is the invisible bottleneck choking the AI boom? See, because AI is digital, it's incredibly easy to fall into the trap of assuming it just scales infinitely up in the cloud somewhere. But the truth is, the path to artificial general intelligence is strictly capped by the physical world. If you want to know where the real alpha is hiding right now, you've got to look for the missing links in the physical manufacturing stack.
Section 1. The hardware wall, logic fabs, and packaging.
Okay, let's dive into this reality. We need to move our focus past just the design of the GPUs themselves and stare straight at the advanced logic fabs and the highly specialized packaging facilities required to actually build them. The abstract concept of an AI boom is crashing headfirst into an industrial wall. Demand for TSMC's N3 wafer is surging astronomically through 2025, 2026, and well into 2027. All the major accelerator roadmaps, whether you're looking at NVIDIA, AMD, or Broadcom, they've totally converged on this exact N3 process node. And you can't just flip a switch to build a state-of-the-art clean room. You have to source insanely complex ASML lithography machines and construct facilities with zero margin for error. TSMC's utilization for N3 is expected to blow past 100% in the back half of 2026, and the lead times for expanding this physical capacity are measured in years, not months.
But it gets even tighter when we look further down the line, 113%. That is the staggering annual growth rate in demand for TSMC's advanced packaging, specifically their CoWoS platform. Every single leading-edge AI chip requires this 2.5D interposer-based packaging. You can think of CoWoS as this unbelievably complex, microscopic highway system that lets the logic chip talk directly to the high-bandwidth memory with almost zero latency. It requires sub-micron precision just to line these components up. And despite TSMC aggressively dumping billions to expand their facilities, this crucial step is fully booked out through 2026. This isn't just a supply chain bottleneck anymore, it's practically a structural monopoly.
Section 2. The Indium Phosphide disaster.
So, logic fabs and advanced packaging are severely backed up. But if we pivot from the logic chips themselves to the physical connections between them, we hit what the smart money calls a secret disaster. It's a massive, under-the-radar materials shortage that almost no one in the retail market is talking about. Enter indium phosphide, or InP. Now, what's really interesting about this concept is that when you're building an AI cluster with 100,000 GPUs, those chips have to talk to each other instantly to train a massive language model. That requires optical interconnects, it requires lasers, and here is the fundamental unbending law of physics we're dealing with. Silicon has an indirect band gap. That means while it's amazing at computing data, it absolutely cannot emit light. Instead, it just releases energy as heat. To generate actual photons, to make light, you strictly need these specific direct bandgap properties of indium phosphide. This perfectly illustrates the contrast and the reliance we're talking about. On one side, we have silicon. It's the brain. It computes the data, it generates a massive amount of heat, but it sits entirely in the dark. On the other side, we have indium phosphide. This is the voice. It fires the photons, it generates the light, it enables the high-speed lasers, and it's absolutely vital for optics. Without indium phosphide, those massive power-hungry AI clusters simply can't communicate with each other. They're totally stranded. And the technical requirements are only getting more extreme by the day. The industry is aggressively moving toward co-packaged optics, or CPO. This architecture pushes physical limits to the absolute brink. It requires much higher power lasers, which mathematically forces you to use significantly larger die sizes. It demands narrower line widths and strictly better noise performance. Because these optical chips literally have to be physically larger to meet these demands, yielding them from raw indium phosphide wafers is incredibly difficult, eating up way more raw material in the process. The result is a crippling supply chain disaster for indium phosphide manufacturing. Let's move ahead and see how this builds and ripples aggressively across the entire broader supply chain. Because of these insane physical demands, CPO is completely murdering the supply of traditional monolithic EML lasers. It's forcing the whole industry into a rapid shift towards silicon photonics for the next generation 1.6T transceivers. But here is the critical catch that the broader market is entirely missing. Even as hyperscalers rush to silicon photonics to try and save on costs and exotic materials, those specific modules still desperately rely on an external continuous wave laser to power them. And what is that continuous wave laser made out of? You guessed it, indium phosphide. There is simply no escaping the physics.
Section 3. Analyzing Lumentum stock. Ticker LITE.
So the crucial point is that this severe physical bottleneck translates into one of the most highly actionable market opportunities in the AI infrastructure space today. We're translating this heavy physics lesson directly into an investment thesis. As Lumentum CEO perfectly summarized it, we've sold everything out for the next 2 years. You see, in the heavy infrastructure world, scarcity is the ultimate antagonist to hyperscalers like Google, Meta, and Microsoft, who are locked in this AI arms race. But it's the ultimate tailwind for a specialized supplier. Lumentum is sitting exactly at the absolute choke point of the optical interconnect shortage, perfectly positioned to profit from a desperate demand that simply cannot be met by anyone else.
The optical moat indicators here are just staggering. Revenue growth sits at an explosive 90.1%, driven by a massive acceleration in those exact 1.6T transceivers we just broke down. Non-GAAP operating margin is at a very healthy 32.2%, proving that when hyperscalers are desperate for parts, a supplier has incredible pricing power in a completely sold-out market. Institutional ownership is hovering roughly at 94%. That is rock-solid conviction from smart money funds who fundamentally understand the physical limitations of this supply chain. Finally, their backlog visibility shows them actively undershipping demand by 30%, which creates an incredibly durable revenue floor for the next 12 to 18 months. Lumentum is effectively capturing a massive share of the economic value right there in the physical AI infrastructure stack. Now, we've got to decode Wall Street's metrics and address the valuation arbitrage directly. If you pull up the trailing price-to-earnings ratios for infrastructure hardware companies like Lumentum right now, the numbers can look absolutely wild, sometimes swinging dramatically between 174x to well over 480x. But honestly, that is deeply deceptive. When a company holds a verified sold-out order book that stretches out for 2 full years, that acts as a definitive precursor to massive, rapid earnings expansion. Understanding that forward revenue trajectories in these high-barrier physical moats will completely override current PE volatility is crucial. The market prices in the past, but the smart money, they're pricing in the inevitable future.
Section 4. The scarcity premium. This brings us to the situational awareness thesis that's currently being championed by top thematic infrastructure funds. When the entire tech industry desperately needs a resource that physics dictates cannot be easily replicated, that asset earns a scarcity premium. So here is the smart money playbook for the AGI era. First, shift your focus away from ephemeral software apps and look deeply at heavy industrial reality. Second, zero in on the physical constraints, the gigawatts of power, the indium phosphide optics, the multi-year waitlists for advanced logic fabs. Third, target high-barrier, monopoly-like infrastructure nodes, the companies that sit at the absolute choke points of the supply chain. And finally, capitalize on deep technical and physical moats. While the broader market obsesses over who builds the best chatbot, the smart money is quietly buying up the physical layer that makes it run.
Which leaves us with this final provocative thought to challenge your own framework. As the trillion-dollar AI cluster gets built right before our eyes, are you investing your capital in easily replicable software, or are you investing in the unavoidable, irrefutable physics that makes the entire thing possible? Let that sink in. Thanks for joining me on this explainer, and remember to keep your eyes on the physical layer.